Hi there again YouTube, it's AC Dodd and welcome to another thrilling instalment of my machine tools, and this time it's my variable frequency drive high speed converted Colchester student lathe. This is my 1959 Colchester Roundhead student lathe. I've used this machine for many years. It was passed down to me when my father passed away in 2009. I've used this machine now. I used to skim brake discs on this when I was before I was an apprentice, so I used to work for my dad doing various little bits and pieces. So I've used this machine now for more than 30 years, so I'm quite well aware of its capabilities and quite au fait with its little foibles. I've done quite a few modifications to this machine, certainly more recently, and the main one of which is to fit a DRO. So I've got a 2-axis DRO kit fitted on the machine from CBR Electronics. Thoroughly recommend this installation on any old machine because it transforms the accuracy and the price that you pay for it. I had it installed because I couldn't wait. I didn't have time to install it myself, so I got the man down from CBR and he fitted it himself. Excellent piece of kit, works very well, and as I say, transformed the accuracy of the machine. One of the more recent additions was a tool post, and as you can see, that's actually quite a small tool post because I've changed it to a T63 size from the T2 that was on there. There's a number of reasons for that, but we'll go into that later. One of the other things that I've done to the machine, as you can see, this machine originally was quite slow. In actual fact, somebody had actually changed the gearing in it many moons ago, so instead of 1000 RPM as the maximum speed, it would do 1230. So what I've done with modern carbides, that's still woefully slow. So in actual fact, I've modified this machine now with the addition of a variable frequency drive, and I've also changed the motor from a 4-pole back to a 2-pole motor, so it's a 2800 RPM motor. And with some gearing changes, I've actually managed to get this machine to run at 2450 RPM. In reality, I use probably 2000 as the most speed. I don't use the original chuck because that's an original meionite chuck. I've actually got a slightly smaller steel billet, a modern chuck, to go on there when I run the highest speeds. So I do limit the speeds on this to about 1500, 1600 RPM with the original chuck. The other modification there is I've put the addition of an eBay spindle speed digital readout, which helps me determine the actual speeds. I've got obviously a variable speed drive with the VFD, so I can actually forward, reverse, run or jog the motor, and then run that at any particular speed that I need. So in actual fact, this machine still has its 8 gears, and with the ability to vary the motor, I've got any speed between 22 RPM and 2452. The guts of the conversion uses a Jaguar VXR VFD, which it's not a cheap VFD, but I've found variable frequency drives, the more money you spend, the more features you get. Highly recommend the Jaguar range, especially the VXR being the top of the range. This is a 2.2 kilowatt, takes single phase in, turns it into 3-phase variable frequency output, and then that runs a 2.2 kilowatt 2-pole tech motor. One of the other things you'll notice about this machine is it doesn't have a feed gearbox, which has been a limiting factor. And one of the things I've done to get around this is to make sure I've got a full set of back gears to enable me to select or set up any any feed for feeding when cutting materials or any threading that I need to do. With the rear cover off the machine, you can see the back gears there. and those 4 gears there are responsible for changing the feeds. So every time you need to change the feed, either for parting off or roughing out a component or finish turning, you need to change the gears at the back, which adds a little bit of time. But the option here is I've actually got very wide range of feeds available, more so than you would get on a typical feed gearbox arrangement. Now, if you don't have a feed gearbox, then it's very important that you have all the back gears to be able to make all the speeds. Now, it's only taken me about 12 years, I think it was, to actually obtain all these parts. When I first got the machine, I was missing this gear, I was missing this gear, I was also missing I was also missing any 25 tooth gears as well. So by using various means and friends, etc., I've been able to find some missing gears. So I was able to obtain a 25 tooth gear and the 80 tooth gear and a few others from a chap called Toby Walker. So thanks very much, Toby, for that. That's helped me out no end. But also another chap that I'm indebted to is a chap called Alistair Ragg, who helped me manufacture some gears. So I've even now got gears that weren't ever produced for my machine, like this lovely 55 tooth example, which is made out of O1 tool steel. And I've also got 35s, which again were never produced. I also took the advantage of making some spares. So there's some spare 20s, because the original 20 was very torn up, still workable but very chewed. So I've now got some O1 tool steel versions of those made as well. All in all, this gives me more selection of feeds that was ever available from the factory on this machine. So if you do have a machine with no feed gearbox, it's worth investing the time and money to enable yourself to have a full set of gears to make the machine, or make the best use of that machine. So let's give you a quick demonstration of some of its capabilities. As you can see there, it's still showing 22 there, it's just cleared. I'll start the machine in bottom gear at the lowest speed. As you can see, that's doing 22 RPM. And then obviously if I turn up the speed of the motor, you see that's the bottom gear, but I've now got a range of between 22 and 112 RPM. Now if I go into top gear, I can't go up to the full speed because I've got the old type chuck on, but I can go up to a reasonable speed, which is past that of what the machine was originally rated at. So here we go, the machine's sat there and it's reading 0. So let's start the machine. So that's in top gear with the lowest speed on the motor. You can see we've got 500 RPM showing. Now if I increase that, I'll stop there because that's about as far as I want to run that particular chuck. But my point is, with the variable speed drive, I can actually run this much faster, and actually it becomes a lot more useful with modern carbides. The other useful function I've got is I can jog the machine. So just by pushing the button, if I need to jog the chuck round, no problem. I can also start it in reverse. So we'll start the machine and run it backwards. Again, something which this machine was never been able to do. One of the reasons for changing the tool post was to make sure I have enough tool holders. So I splashed out and bought 20 tool holders and put every tool I have or I need for all my jobs into a tool holder, so it's already set. So you can see them all here, already set. All the tools I use for lightening flywheels, boring primary gear bushes, chamfering, you name it, it's basically all there. I use these tool holders in conjunction with this tool post. As you can see, that's a smaller tool post. I actually figured that a small tool post would be easier for me to get in to do certain jobs and be able to see in and around what I was doing. And so far, it's proved to be you know, a worthwhile addition to the machine. And it's sped up no time having enough tool holders for every single tool, and that just makes the machine easier to use. This machine is the mainstay of my workshop, and it's the most profitable machine I have. If you're into the business of making engines, it's very difficult to be able to do everything you need to do without access to a lathe. So I thoroughly recommend, if you're into engines or you're into engine work, then you need to invest in some sort of lathe capability. And I would suggest the Colchester student type lathe like this, even though it's old, is very capable and is able to remove a considerable amount of material when lightening flywheels, etc. And it can do that in fairly short time. Now, obviously, a bigger machine, such as a Colchester Triumph or a Mascot or something like that, would obviously do the job even quicker. But obviously, there's a payoff, or there's a trade-off in terms of size and obviously the power consumption. Speaking of power consumption, one of the things that you have to bear in mind nowadays is the cost of electricity. So one of the things that you'll notice on this machine, using the latest VFDs, that indication there is showing you how much energy this machine is pulling from the mains. So that is 250 watts. Now, if you was running a direct online 3 horsepower motor, you're probably pulling somewhere in the range of 1.5, maybe 1.6 or 1.7 kilowatts. So as you can see with the VFD, you only put the energy in when you need to accelerate the chuck, and as it comes up to speed, the energy that's going into the machine or into the motor is only that it's needed to maintain the speed. The other good thing about this machine is when you load that machine and put a cut on, the VFD will automatically compensate and maintain the exact speed that you set, and that's very useful when you're in the cut. I also have another addition which I can fit to the back. There's 4 bolts there which I can bolt a grinder to, a bench grinder to, so if I need to I can grind any diameters. Useful for when touching up shafts and things, or if I need to sharpen my lawnmower. Another modification I made to this machine was the addition of a sliding stop. This basically means that I can use this together with the two extra stops there, and it gives me an option to slide the bar up and down, and gives me a couple of options for selecting stops for the bed. As you can see, when the bed comes up to it, once that's set, you can set that in any position and it acts as a nice stop for the machine. I also do have the original, or one original stop for the machine, which was actually, I obtained this from Slark Race Engineering, and that enables me to use a conventional stop, but because I've got now 2, I can use one on the back. So I can limit the stop on the front and limit the stop on the back. I also have fixed and running steadies for the machine, although they weren't part of the original machine when we got it. I got them again from Slark Race Engineering when they had a machine, an old Colchester that they sold for scrap. I took those off them and used them on this machine to maximise my capability. All in all, the Colchester machine serves me very well. Although I do often find myself thinking I need a bigger machine, but I think that's the mentality that bigger's always better, but that's not the case actually with machine tools. The right size machine is what you need to do the job, and in this case the Colchester Student Roundhead works perfectly for me. Well, that ends this little quick rundown of my Colchester lathe. If you see anything there, or you've got any questions about the conversion or what I've done to the machine, then please put down a question or whatever in the comments below. If you want to see any more or help me make any more videos, then please like and subscribe as usual, and I look forward to speaking to you soon. Take care.